Hey everybody, and welcome back to this R in Quantitative Finance series. This is going to be the third video on portfolio optimization. Now, portfolio optimization can be a pretty bewildering topic to a lot of people, especially if there's not really a background in quantitative finance or really any mathematical concepts within finance whatsoever. Now, what's important is that portfolio optimization isn't really that complicated if you have the right tools for the job. In my opinion, R is definitely the way to go for this, and we're going to be using the performance analytics package with Quant to get our data here. But really, all portfolio optimization intends to do is to match an objective. Let's say we want to minimize the variance of our portfolio while maximizing the return and or expected return, and that's probably the most common objective in portfolio optimization. That is part of modern portfolio theory by Harry Markowitz. But essentially all we need to do that is modify the weights in each asset we have. Because if you think about it, each asset has an expected return and a standard deviation, right? So from there, if we had a data set, right, we could have our daily returns or monthly or whatever, and we could calculate a covariance matrix. And with the expected returns of each stock, we could use all of that in conjunction to optimally allocate the weights to each stock to match our objective to minimize the expected return or maximize the expected return and minimize the risk of our portfolio. Now, that's might sound a little bit complicated, but there are a lot of different objectives we can choose. Now, that's probably one of the simplest and the most widely used, and I just wanted to give a brief overview of what portfolio optimization aims to do. Now, Ross Bennett, the author of the PortfolioAnalytics package, actually has this nice tutorial publicly available on his GitHub. And he actually goes into portfolio optimization a little bit here. So you can see he goes into modern portfolio theory, and the different objectives he uses, or we can use in portfolio analytics. And to get back down to what really needs to be said here is that when we use portfolio analytics, this is what we're trying to do. We're passing in a set of returns, right? Different assets. And we are constraining our portfolio in different ways. I didn't mention this, but we can constrain our portfolio by, say, for instance, allowing shorts, right? So if we want to enable short selling in a portfolio, that could be a constraint that was enabled. In this case, we're going to do long only, so that's going to be a constraint. We could also constrain our portfolio by saying, all right, now we want to only allocate, or let's say we only want to have a minimum of 5% in each asset that we invest in and a maximum of 20% in each asset that we invest in. That could be another constraint. There's a full list of constraints in the documentation, which I'll link in the description. And it's really, really useful. We're just going to choose simple constraints and simple objectives in this case. And the objectives, as we already mentioned before, are minimizing the standard deviation and maximizing the return of our portfolio. In terms of asset return moments in this framework here, that's really eloquently explaining how we're doing everything. We don't need to worry about that. That's more of complex optimizations. Now, we're going to go over complex optimizations probably in the next tutorial, but for this case, this is all we need, these three. And we're really just going to pass these in and get our optimal portfolio. And our output is just going to be a set of weights, basically, for each stock that were optimized, and an expected return and mean, dependent on our objective. So let's go back over here. Now, the first thing we want to do is make sure we have a portfolio object. So that's going to hold our constraints and objectives. So we will initialize that right here. So we'll say port F equals pspec, or it's actually portfolio dot spec, and we need to pass in our asset names here. So I'll do call names, portfolio returns, and let me highlight and run all this right here. Cool. So we have our data, and this was all from the previous tutorial. This is nothing new here. So I just changed the ticker symbols, I believe. Now we can initialize our portfolio object, and now we can pass in some constraints too. So we'll say portf equals add dot constraint, and we need to refer to the portfolio object we created. And let's say for the first one, this is going to be our no shorts constraint, I guess. So we'll do weight underscore sum, and we'll say min underscore sum equals 1, and then max underscore sum equals 1. And there's another constraint called full investment, but this does the exact same thing. It's just saying, hey, we have to sum to 1 in this case. So the next constraint that we'll add will be a box constraint. So that's for each individual asset. So we'll do a minimum of, let's do 10% in each asset, or a maximum of, let's say, 40% in each asset. So the next thing would be the objectives. So let's do portf and then add dot objective. And in the objectives, we can also refer to our portfolio object. And we want to say, for this one, we're going to maximize the return. And we need to pass in a name as well when we do optimize, because when we're graphing, it is going to look for this name right here. So if we're going to graph the frontier, this is integral. So add dot objective, and this is just going to automatically maximize the mean and minimize the expected return, or variance, if we don't pass in a target number here. So we're just saying, all right, minimize it and maximize it. So we'll say risk, and then name equals standard deviation. Okay. So these will be all our constraints and objectives. I think I made a typo. Cool. And right now we're ready to optimize our portfolio. So one thing to keep in mind is that we are going to have to use a solver to basically solve for these weights. Now I'll say opt port is equal to optimize.portfolio. And I'm going to pass in first our portfolio returns. Next, the portfolio we created. And next, the optimization method. And that's going to be the solver we're going to use. There are different solvers you can use in PortfolioAnalytics, but for this case, we're going to use ROI, which is used for simple optimizations like this one we're doing, just a simple mean variance optimization. In the next tutorial, I'll probably go into different solvers and why you'd use some over others. But in this case, this is all we really need. So another typo. So it's pretty fast. It's not always going to be this fast when you optimize, especially when you have complex constraints. So you can see right here, these are our optimal weights for our portfolio. Here's our mean, not annualized, and our standard deviation, not annualized as well. Yeah, that's basically all we really need to do an optimization in this case. It's just a super basic one. We can visualize the optimization also. And we can do this in a number of ways. So a lot of people would probably want to visualize the efficient frontier. We can also chart the weights too. Chart weights, opt port. So let's do that from the start. And you can see right here, here are our weights. Nothing crazy there. So let's go on and extract the efficient frontier from our optimal portfolio. And I haven't really tried to use this function that much, but I think I need to pass in. Let's look at some documentation. Extract efficient frontier. Oh, we have to match column. Okay. So I can just copy that and paste it right in. I'm going to pass in our optimal portfolio, and I'm going to match on the standard deviation column, and let's see if that works. Oops. Okay. I believe it's actually a trace that we need to put in order to do that. Okay. Now that should have our efficient frontier object, and I'm going to assign that to a variable, and then we'll say chart efficient frontier. I'll pass in that, see if that'll give us anything. Okay, so we probably have to do that same exact thing and look at the function. So this is super useful in terms of looking up what we need to do for documentation. So it looks like there's an example right here for ROI, which is the one we did. Now we're going to pass in our extracted object and change the max call or match call. Okay, let's see if that works. And cool, there's our efficient frontier. Let me try and zoom that out. Okay, awesome. So you see how absolutely easy that is. Sorry for the confusion right here, by the way. But this is why we have to keep the naming conventions here to make sure if we're graphing anything that we can actually visualize what we want to do. So yeah, that's really it for this tutorial. Again, here's the efficient frontier. And this is just supposed to be a very simple tutorial on basically creating a optimal portfolio and visualizing the output with the efficient frontier, which is something that's very standard. So I hope that was easy enough for everyone. And yeah, rate, comment, and subscribe, and I'll see you in the next one. Bye-bye.